Hello, welcome back to manufacturing and prototyping. Gonna go ahead and start off this lecture by talking about value engineering. This is also referred to as value analysis. Okay, so, whoa, odd moment where I just blurred out. I did that in real life, that didn't happen on the camera. What is value engineering? Well, it's got the word value in it, it's got the word engineering in it, so this is the part where engineering is a mixture between applied physics and applied business, where both of those worlds run together. In this type of environment, value engineering is another one of those mixes. This has to deal with the business side of things, this has to do with the engineering side of things. It's a direct marriage between the two concepts. So the idea behind value engineering is every engineer is going to run into the issue of quality versus cost. Okay? I can make something nice or I can make something cheap. Usually it's one of those two. Now, as you go along in the design process, you end up trying to increase your quality and decrease cost. Sometimes what that means is you look at different processes. If you're ordering in parts from another supplier, maybe you invest in the equipment that allows you to make those parts yourself. So it's one way that you can save cost by investing, but over time it actually ends up saving you money. It has to do with a lot of cost analysis. If you've done any macroeconomics, this is your future over present value analysis, present over future value analysis, present over annuity value analysis, all of these different types of analyses. This is where some of this comes into play. Okay, we do that as a regular part of engineering. Value engineering is something that is a little different though, okay? Now, the way that the textbook for this course describes it, value engineering is part of that process. Looking at improvements, looking at how to cut costs in the manufacturing plans, looking at ways to reduce the cost in the manufacturing process, reduce the amount of material to overall reduce the cost, reduce the construction time, reduce the time for assembly, or reduce the time for manufacture. All of those are issues that go into value engineering. So, according to the textbook. I'm going to give a little bit of a caveat though, because value engineering is slightly better than that. So, issues that are brought up in value engineering is ultimately the cost of machines. Every machine has not only a present cost, which is the purchasing cost, it also has a maintenance cost, and also has a time cost associated with it. Every machine takes a certain amount of time to operate. And this goes into, how many operators have to be present. How much time do the operators have to put into this machine in order for this machine to operate. So every machine has a number of costs associated with it. Here, this is a present value. Here, these are more annuities. Okay, but beyond just the cost of machines, you're looking at the cost of materials. Would one material be better than another? You're also looking at the cost of labor. I hate to say this, but in today's world, we're looking at finding ways that we can either make people more productive or we can not need as many people. One of those two. We have a severe shortage of workers in America right now, particularly in Nebraska. This has become a big issue. I can't find somebody to work. How do I continue to operate even though I can't find somebody to work? This is where we end up moving more towards automation and finding cheap automation solutions to implement. Okay, we've talked about Six Sigma. We'll talk about lean engineering, but you have the overhead. Anytime you make something, you have to store that something. Anytime you order something, you have to store that something. Anytime you store something, it means that's time for you to take whatever it is, receive it from the shipping dock, put it into a storage location, document that it's there, find ways to make sure that your own company is aware of these products. And then you may have maintenance associated with it. If those parts can't be dried out, or if those parts can't get wet, you might have to do some special engineering to ensure that these parts are taken care of. And that may also take up a very certain amount of floor space. And when you're ready to finally move them, you have to transport some of them, maybe all of them, to where they're supposed to be. And that's more time and more effort. Just bringing in materials, sometimes just the act of having things on the floor costs time and money. Okay, but above that, you've got costs associated with management. You have costs associated with the fact that there are workers present. You have costs associated with the building. You've got costs associated with the location. A lot of manufacturing was moved over to China because there's just a lower overhead. Buildings are cheap. Land was cheap. Labor was cheap. And all of those contributed into not just labor and overhead, but also into the overall cost of the product. You make stuff for cheaper when everything else is cheaper, when these are cheaper. Okay, so value engineering looks at all of the different potential cost inputs into a single part and tries to find ways to minimize them. Okay, when you're doing something very large scale like manufacturing light bulbs or manufacturing mechanical pencils, if you can save half a penny on all of those items, if you can save a tenth of a penny on all those items, it can count up to hundreds of thousands to millions of dollars within a year. For higher cost items like an ATV or for like a vehicle, you save a tenth of a penny and you've done absolutely nothing for that vehicle. So there is some discretion that's needed here when it comes to value engineering. Okay? So let's talk a little bit about the discretion before we move on with talking about the process. So some discretion is needed. And a lot of that has to do with volume of costs. If you have 100,000 people who work for your company, if you lower your hourly wage by 1 penny, so 100,000 workers times a 1 penny pay reduction, I'm not saying this is ethical, we're playing a game, you are saving $1,000 every working hour. Now, are these employees going to be feeling 1 cent different? Probably not. You're saving $1,000. Now you pay a minimum wage instead of paying a standard $15 or $18 an hour. You go down to $10 an hour. Now you're saving 100,000 low-skilled workers times $5. That's $500,000 every hour you're saving by treating your employees terribly. This is why companies do this, because it comes down to, okay, this is a lot of money. This is a friggin' lot of money per working hour. Okay, per working hour. If you have a working hour, and let's say maybe you only have 25,000 employees at a time, working on average every hour of every day. Okay, so 25,000 employees working every hour of every day. You cut all of their pay by $5. You're saving $125,000 an hour. Well, let's do some fun math. Okay, that means every day you are saving $3 million as a company just by treating your employees terribly. Okay? $3 million a day. If you assume that there's 250 working days in a year, which is 50 weeks times 5 days a week, this is now $750 million. Just like that. You just saved your company $750 million by treating your employees wrong. Now, the issue you're going to run into is that employees don't like being treated poorly, and they leave. And then you can't find somebody to work for $10 an hour for you. And then this no longer becomes a cost savings, this becomes a burden because your company shuts down. So it's a part of value engineering that it's the darker side. But treating your employees poorly does change for it. Now, let's say you are a construction firm, okay? And you buy concrete, okay? Every year you buy concrete from the same company. Now, let's say you just have a really good working relationship with them. They're very reliable, really good company, but they're selling that concrete to you at, I don't know, $500 per 10 cubic yards. Okay, which is a really nice deal. But when you're building bridges and buildings and you consume, maybe 100 cubic yards per day. Okay, means you're spending $5,000 on concrete daily. All right, but then your competitor to that company comes in and maybe they're a little shady, but they're offering you $480 per 10 cubic yards. Okay, $20 difference. Well, that's $200 a day, just savings in concrete. Okay, for an engineer, like, all right, save money, $200. Well, but this may come with problems. Can they deliver it on time? Are the drivers reliable? When they show up there, are they going to be drunk out of their minds? Are you going to be dealing with a guy who has no idea what he's doing? Is he going to be combative? Is he going to come at you? You maybe $20 per 10 cubic yards. That may not be worth this cost. Yeah, sure, they pay their employees worse. That's why they were able to cut their costs on concrete, but it also results in worse quality performance from what you get. Is it worth it? Well, this is where some discretion is needed. This isn't a lot of costs daily. $200 a day isn't a whole lot. You might lose $200 a day because a guy doesn't show up. If you were supposed to pour 20 cubic yards of concrete, or you're supposed to pour 100 cubic yards of concrete, you're supposed to spend $5,000 or $4,800. Instead of saving that $200, you now lost $5,000 because a guy didn't show up. That's a lot of thing, and then that pushes you back a day, and that means all of your workers waiting for that concrete. Now, you may have 5 concrete workers. You may be paying them $3,000 to try to save $200. You just spent $3,000. Wasted time, wasted effort. Okay, so there is a discretion that's needed in value engineering, and some of it has to do with the volume of costs. If you have a larger quantity, if you used 100,000 cubic yards of concrete a day, that's a big expense. That's now not just $5,000. That's now $5 million worth of concrete you're spending daily. And if you can save $200,000 a day, that's a big deal. $200,000 a day for some sketchy work, a lot of companies would take that. Okay? So volume costs matter. But now you're also dealing with reliability. And now you're also dealing with the ultimate end of quality. You don't want your end product to be terrible. And this is the idea behind what value engineering is, okay? So, when we go to define value engineering, this is satisfying functional and quality requirements at lower costs. Okay, that's really all it is. Now let's break down this definition, okay? Satisfying functional requirements, okay? So, functional requirements. If you remember this from EGR 210, functional requirements are what physically a product must do. Okay? When I buy an Expo marker, it has to write. I have to be able to hold it. It has to contain all the fluid without it leaking out all over my hand. Those are all functional requirements. Okay? And here, I have always framed it to you as the idea that a functional requirement is a need. It is a yes-no condition that absolutely must be met. If you satisfy a functional requirement, yes. Does this contain its fluid without leaking? Yes. Does it write? Yes. Therefore, it has satisfied its functional requirements. Okay? On the flip side of that, there are also quality requirements. And that is how well a product performs. Now in EGR 210 I talked about measures of quality. Measures of quality, MOQ, big idea in engineering because it's something there. You have your functional requirements, you have your quality requirements. Your MOQ, some values are going to matter more than others, okay? If your customer base doesn't care that this isn't sustainably sourced, you don't need to sustainably source this. Value engineering. If your customer base does not care whether or not this leaks all over your hand, you don't have to do that well. You can just make sure most of the fluid stays in. If your customer base doesn't care whether or not the cap shatters, or whether or not the cap even fits on well, that's a measure of quality. And those are things that fit into this. More than likely, your customers are going to care about lifespan. I want a marker that lasts well. Your customers are also going to care about erasability. I want a marker that when I'm done with it, I can remove it from the board and move on with my life. Hence, dry erase. Okay, those are functional requirements that are top priority. As long as I can meet the basic expectation of what is expected from my consumer base, I don't have to use Expo brand. I can use knockoff brand. And I have used knockoff brand, and I am not impressed with them because they don't meet my quality requirements. They're actually really hard to erase. I don't care about the lifespan. I can't erase them. I won't buy knockoff whiteboard markers because they don't meet the quality requirements. So when we talk about value engineering, it's important that we meet functional and quality requirements because otherwise people won't buy them. Now, the big thing here is what makes this value engineering is that the ultimate goal is to lower costs. Okay? Why do we lower costs? Why is it important to lower costs? Well, it's you have your supply and demand curve. If you reduce the price by some percentage, you will see an increased demand in your product demand. The cheaper your product is, the more people will buy them. That's supply and demand. That's the very nature of business model here. So you can make more money selling more product if you just cut costs a little bit. Second, this is more sustainable. If your company starts going under, your low-cost production methods are oftentimes what saves them. Okay? It's the whole reason why auto companies produced really terrible vehicles back in the 90s. Because selling really terrible vehicles was just free money. You could cut costs a lot and sell them for slightly less. People think they're getting a great deal. They're getting trash. But people think they're getting a great deal. It's more sustainable. It's a good source of income for the company. I'm going to go ahead and go here. Online education in the educational environment is much cheaper. It significantly cut costs at the expense of the fact that you no longer have a very personal relationship with your educator. And you have a more difficult time having somebody keep you on a rigorous schedule. Plus there's concerns with, how do you contact them? When do you contact them? And what kind of wording it is? How do you perceive them? How do they perceive your questions? So it is a lot of cost savings because it doesn't require a physical environment. It can be done remotely. It can be done over videos like this one, ironically. But on the flip side, there is a reduction in quality. Now, is that quality satisfactory? For some people, yeah. It makes the university a lot more money at the expense of the student educational experience. So there's benefits to doing this, and universities are making hand over foot money over online education. However, the students aren't exactly all that happy with it, which is why universities haven't disappeared yet. We still have them because people apparently like being educated in person. I'm one of those people. Okay, so lowering costs benefits both the consumer and it benefits the manufacturer itself. End of the day. It's a net win on everyone. Manufacturer wins, consumer wins. And this is kind of the idea of capitalism. Reducing costs makes people want to buy things more. So in a capitalistic society, reducing costs on everything is going to spur the success of businesses. That's kind of how things work. It's a great piece of capitalism there. I will not teach manufacturing outside of a capitalistic environment because a lot of the business principles die outside of capitalism. So, my little shtick. I usually don't go into politics, but quite frankly, supply and demand it fuels most of these intellectual decisions and quality. So what is the process of value engineering? Okay, here I'm going to access my notes. Oh, yes, I would like to take a survey. So first, we need to understand costs. Okay, when we look at costs as a whole, we're not just looking at cost to manufacture, but we're also looking at long-term costs. Okay? I was just remarking to myself today about how if you watch any videos on the recommended procedure for recycling, you are supposed to remove all labels, wash all of your recycling items. You're supposed to separate all of your recycling items so that individual pieces are dealt with independently. You're supposed to put a lot of effort into throwing away your trash, which is a problem because that's a cost. If I spend 15 minutes getting my trash ready to throw away, that's 15 minutes when I could have just like shunk straight into a trash can. And I don't care about whether or not there's a label or whether or not it's clean. It takes some buy-in. There is an associated cost on the consumer end with every product. So I may have the greatest recycling capabilities in the world, but if it requires me to have all of these people go and put an extensive amount of effort into making sure the recycling is valuable, it's not going to be successful in the end. Okay, we have to design a process by which we can separate things ourselves. We can do it automatically without requiring a substantial cost for the user. So one example, but here the book has a figure that they put in this chapter where customer needs ultimately drive the design process. Okay, from the customer needs, this goes into planning. From the planning stage, it goes into development. From development, it goes into design, purchasing materials or procurement. Procurement also includes equipment. And then you move into production. And then you move into sales. Okay, now all of this is the cost to manufacture. You take all of these associated costs, sum them all together, and put them into how many products you will produce over the lifetime of that product. That's the total cost to manufacture a single part. Okay? But this isn't where the costs end, because now it has been sold. And now the consumer takes over. There's a cost associated with use. When you use a vehicle, you have to pay gas, you have to pay oil, you have to pay fluids. Okay? Beyond that, though, you also have to pay for maintenance. You have to make sure that that vehicle is well taken care of. At the very end of it, once you've paid for maintenance, you're going to have to pay for disposal. Now, a lot of vehicles you'll actually make money off of, but there is an associated time cost with it. You have to find somebody to sell it to. You have to spend the time listing it on the market. If your car is trashed, you have to haul it to somebody who's going to scrap it for you. Okay? There's a cost associated with that. There's a cost associated with everything. Whether it's time, whether it's actual money, whether it's resources. There's costs associated with it. So as we put ideas into this, what we're doing as we go through this process is we're asking at every step, how do we save costs? Okay? And specifically, time, resources, and overall cost, money. Okay? We're asking all three of those because all three of these are a type of cost. So, how do we reduce costs in the planning process? Well, we can just reuse something we've already done. We've now saved time. And we've also saved resources because now we're saving employee time. They don't have to spend time in that. And you're saving the paychecks. Not as much money gets put into planning when you're just building off of an existing design. Development. Building off of existing equipment. Maybe you're only making a slight part change to an existing piece. Cough. iPhone. Cough. Samsung Galaxy. Okay, slight changes. Not a huge amount of development goes into very slight changes. One piece upgrade, maybe a little bit of user upgrade. That's it. It's not a huge amount of development. You save costs there. How do you save costs in design? Well, in the design phase, if you're reusing existing parts or using standardized parts, you don't even have to design those. Just be like, boop, done. We know how to order them. We know how to manufacture them. We know how to acquire them. We can just ship them in. Okay? Buying standardized parts are there. Utilizing your existing supplies. If you make one part really well, use it again. They do that a lot in manufacturing. They got a lot. If you have ever done any research on the toy company, what was it in the 80s? I I don't remember which company it was, but they were manufacturing Star Wars toys. And they took some other characters and either they turned them into Star Wars toys or they took the Star Wars toys and turned them into something else. I don't remember what it was. But they were just reusing existing parts and just painting different designs on them. It saved them all of this, all the way up to here. And then it was just this on was their expenses. Saved them a lot of money. Those toys are actually worth a lot of money today because they were trash. But it was because they were very rare. They were supposed to be Star Wars toys and they were used elsewhere. Or they were supposed to be Star Wars toys and they were made into Star Wars toys, which in a collector community that makes them more valuable. Okay, but every time, every piece of this process, we're looking at how can we save money. The whole reason why we have value brands of cereal is quite frankly because we make cereal with lower quality standards. Quality standards that match what the consumer wants. But quality standards that aren't as good as, you know, the name brand cereals. Your name brand cereals are going to be your highest quality. Your name brand vehicles are going to be your highest quality. You go buy a knockoff brand of vehicle, which no company wants to be called knockoff, and I'm not going to insult any companies by calling them knockoffs. But you go to buy a, you buy an Audi, you buy a Ferrari, you buy a Lamborghini, you're spending money on quality. You buy a Lincoln, you buy a Lexus, you buy a Chrysler, whatever, no, not Chrysler, Cadillac, sorry, not Chrysler. Chrysler is trash. No, you buy a Cadillac, you buy a Lexus, you buy a Lincoln. They're not nearly as high quality as your Lamborghini and your Ferrari, but they're still very high quality. And then we can keep going down till you get to your Ford, Chevy, GM, a Hyundai, Acura, Subaru, Suzuki. You just keep going down the quality chain there, okay? Until you get a vehicle that is the lowest possible quality, which is a Chrysler, at the lowest possible cost. And that's value engineering. They have cut the costs. There may be some sacrifices in quality, but to make that happen. Now, when it comes to value engineering and actually doing the analysis, the value engineering process is like this. Let's say we have 4 alternatives. Okay, maybe alternative A is we use a different type of material for our machining processes. B is we use a different type of machining process. Maybe C is a different type of machining process as well. Maybe D is a different type of material as well. What we do is we evaluate them all on quality and cost. Okay? At the end of the day, you want quality to, at best, stay the same. At most, increase. And you always want to make sure that costs decrease. If the cost stays the same but the quality increases, that might be something your company considers, and that might be part of value engineering according to how the book defines it. But to me, this is not quite value engineering, it's just improvement of product. What you really want is to both have the quality improve and have the cost improve. If you have either the quality get worse or the cost increase, this option is now not viable. So that's the fundamentals behind value engineering. Again, the goal is how can you cut costs? Maybe cutting costs around quality, maybe not producing the highest quality of product possible, but producing an acceptable level of quality. Keyword there, acceptable level of quality that matches all of the functional requirements at the lowest cost. All right,